Hi, this is Mick Elliott of Electronic Specifier. I'm on the Rohde Schwarz stand with Ian Jannasch of PE Systems. And PE Systems have recently joined in a collaboration with Rohde Schwarz. First of all, Ian, can you just give us a little bit of background on that collaboration?
Yes, it basically came from a research project that our company was running. And the problem was identified. One of the reasons was if in power electronics, when one do measurements, one of the big problems is the reliability and the traceability of your data and the management of how data is managed. And also when you're doing double pulse testing, keeping to a standard. There's a lot of different tests out there. Not everybody's sure if they can trust their measurements. So then we've set out and designed the double pulse test that has that you can really use to manage your data, know who tested what under what circumstances, and it's doing it in a really well-defined environment, well-defined standardized environment.
Just give us an idea of the expertise that PE Systems has brought to this collaboration.
So PE Systems, we are power electronics people, and we love what drives us is the automatization of power electronics. As just mentioned, power electronics is a really physical labor field, and that is something we looked at and said, it doesn't have to be like that. It can be done better. Like nobody would go today and still lay out a chip by hand, a CPU by hand. But why are we doing that in power electronics? So PE Systems as a company, we've set out and trying to automate as much of the power electronic design process as possible. The double pulse tester is really the best way to start off with, because if we have great data about our power modules, and we manage that data really well, the sky's the limit.
Got a little demo here. Can you talk us through this?
Okay, so the double pulse tester, as you can see here, is meant to be modular. You can exchange the DC link, you can exchange the component. It's not soldered on. We press down the module onto the contacting plates, contacting PCBs, all by force, by a specific defined force for each module. It will be different, and it can all be hot swapped. No soldering, nothing necessary. It goes really fast. Then what we currently have in there is a 1200 volt, 780 amp half bridge module called the Roadback from Hitachi, and that's what we're showcasing at the fair this week. I think we should head over to the software so we can actually make some measurements. So this is basically where you set up your measurement. You can choose your oscilloscope. We've incorporated all Rohde Schwarz equipment onto our double pulse test into our software, so that's not a problem. I'm just selecting the right equipment right now and going over to the measurement page for some measurements. Measurement page. So this is the page we actually set up a measurement. We can sweep over temperature, DC voltage, current, and also your gate driver characteristics. So that means the gate driver voltage and the gate driver on and off resistances. That can all be set from the software and swept over. For now, we're going to just test at 700 volts and test at different currents. For simplicity, we're just going to do a very simple sweep from 200 to 600 amps in 100 amp steps at 700 volts. So once we've defined this test parameters, I can actually start the test. As you can see behind you there, the oscilloscope is actively triggering and measuring. And as this is happening, it's sending over the raw data to the computer, which does the automatic deskew and the calculation of all the useful values that we want to get. The first measurement, second one actually has already come through, and you can see there's already been switching energies, switching times calculated for us. It shows the curves. And I think the really cool thing to see here on the right-hand side is the switching energy dependent on current graph for the turn on and turn off is being automatically plotted as the tests are going on. So by the time this conversation will be done, we would have made a graph that would take, in the traditional sense of designing of testing a power module, probably a week. We've done in a couple of seconds.
And just to sum up, what's been the interest at the show so far?
Fantastic. Everybody is like I said, the amount of effort this saves you in testing modules is fantastic. So from the manufacturers of these modules to the system integrators, people that actually build power electronic systems, both are really excited about the possibilities this can bring for them.
Ian Jannasch from PE Systems, thank you very much.